Alright, this is going to be the last video and the last concept that we're going to do in graphing rational functions. And the one thing that we're going to add in here is a case that we haven't seen is when we're going to get slant asymptotes. Now slant asymptotes basically means that you're going to get a graph, it's not going to hit it, but it's going to be slanted, meaning it's going to have a slope. It's going to look something like this, right, if I make it dotted. So it's going to have a positive or negative slope. These are going to replace horizontal asymptotes. You can see here how I have HA or slant asymptote. You either get one or the other. Now this is going to be the only new step. Everything else we're going to do the same. The VA is still going to be the same. How to do that, set the bottom equal to 0. We're still going to find the intercepts. We're still going to plot additional points. And at the end, we're still going to see if the graph is even, odd, or neither. All right, let's look at this one. The VA is very apparent. The bottom here is x plus 1. So x could not equal negative 1, so that's our VA. So if x equals negative 1, I'm going to graph this. Here's the dotted line, x equals negative 1. So it's never going to hit that. Now, this is what's different. You always look at the degree to figure out what the equation is going to be for the horizontal asymptote. Now, this is one we haven't seen before. This is where the degree up top is bigger. When the degree up top is bigger, we don't get an HA. Really, the only two cases we've looked at so far is when the degree was the same, top and bottom, or when the degree was bigger in the bottom. Now it's bigger up top. So this is where we're going to get, I'll have this abbreviated SA, this is where we're going to get a slant asymptote. Now, how are we going to get the equation for this? We're going to go back to good old long division. Okay, we didn't do, remember I showed you a little bit, but we didn't do it a whole lot. We mostly did synthetic division. This, you have to use long division. All right, so for this, I'm going to take the x plus 1. I'm going to put the work up here. And I'm going to divide that into the x squared minus x. And what's going to happen, whatever I get in the top, that's going to be my equation for the slant asymptote. Okay, let's look. Remember, we're doing how many times is x going to x squared? Well, that's x times. Then I distribute. So remember, I distribute x to this x and 1. So x times x is going to give me x squared here. X times 1 is going to give me plus x. So let's do that. So I'm going to get x squared, and x times 1 is positive x. Then I subtract x squared minus x squared cancels out. Negative x minus x, right, gives me negative 2x. And then I ask myself, all right, how many times is x going to negative 2x? And that's negative 2 times. Then I distribute this negative 2 with the x. I'm going to get negative 2x here. And negative 2 times 1 is going to give me negative 2 right there. So I'm going to have negative 2 times x is negative 2x. Negative 2 times 1 is negative 2. And then when I subtract, these cancel. And this is going to give me a remainder of negative 2. Now the remainder is really going to be useless for this. We're not using the remainder at all. You can just kind of cross this out. I really don't care about it. Whatever I get up here, this is going to be the equation for the slant asymptote. So it's going to be y equals, and what I just circled there, x minus 2. Now really what you're doing here is you're graphing a line, but it's saying this line, y equals x minus 2, the graph of the actual function is never going to hit it, except it's going to get very, very close to it, get closer and closer, but not quite hit it. So I'm going to graph this x minus 2. Okay, my y-intercept there is negative 2, so I'm going to plot this point. And then the slope here, since it's just x, the slope's 1 over 1. So right from here, I just go up 1 to the right 1, I'm going to plot a point there, up 1 to the right 1, I plot a point there. So I go up 1 to the right 1, I have a point here, up 1 to the right 1, I have a point here, and let's make this dotted. Right, I don't make this solid. Now if you look, you kind of have three, how many regions here? We have 4? Let's see here. Yeah, this is a region, 1, 2, 3, and 4 right here. And really what's going to turn out, when you have ones with slant asymptotes, you're only going to get graphs that are in, I believe, 2 out of the 4 regions. And how can we do that? Well, let's find our intercepts. Okay, let's leave this in red here. X-intercepts, again, I set the top equal to 0. So I'm setting x squared minus x equal to 0. And if I want to solve for x, I can pull an x out. And on the inside, I get x minus 1. So here I'm going to get 2 intercepts. I'm going to get 0 and 1. So I'm going to have 0, 0, and I'm going to have 1, 0. Okay, let's plot these. This is at the origin, and this is at 1, 0, which is right here. All right. Okay, y-intercept, let's let all the x's equal 0. So this would give you, what, 0 squared minus 0 over 0 plus 1. Well, this would just give you 0 over 1, which is 0, and that makes sense because it's this point here, 0, 0. So that's also an x and a y-intercept. Now, when I really look at this, okay, I have points. Really what I should have said is I still just have 2 regions. I said 4, but forget what I said. I think that might confuse you a little bit. Let's go back to what we learned before. I have 1 VA at -1. Really, I just have 1 region to the left of the VA and to the right of the VA, region 2. Now, I have points in region 2, so I'm going to cross this out. Let's plug in a point to the left of the VA. It's -1. Let's plug in -2 to this function. Okay, so if I plug in -2, let's see here. I'm going to try to squeeze this in. I'm going to have, -2 squared. That's got to be in parentheses. Minus -2. And it's over -2 plus 1. Let's see here. In the bottom is -1. In the top we get 4 plus 2, which is 6. So this is -6. So that point we proved is -2, 6. Right, we got -2. Oh, I'm sorry, -6. So let's plot that, right? If I plot that -2, here's -2. I go down 1, 2, 3, 4, 5, 6. It's right here. -2, -6 is right here. Now I have points in both regions, so cross this out. And then graph it on your TI Inspire. Okay, at this point you should graph. And then what's going to happen, okay, I'm going to put this in red, it curves up like this. Then when it gets to the asymptote, it really looks like a line. Like I'm going to make this part a line right here. I'm going to emphasize it. Okay, because it gets closer and closer to that line, y equals x minus 2, but it doesn't hit. Same thing in the bottom region, it kind of curves down here, and then when it gets closer to the slant asymptote, it looks like a line. I call these, the ones with the slant asymptotes, I call these the Nike swoosh, because when you look at the Nike swoosh, that, you know, the part where it goes to the right, it curves, but then it looks like a line, and that's what happens here, and that's what happens here right there. So I'm just emphasizing that. And if you really want to check it, you could also put in, like you put this x squared minus x into your TI Inspire, put in a second equation, put in this, y equals x minus 2, and you'll see you'll get this line right here, which will be very close to your graph, but it won't quite hit it. And we'll kind of go over that in class as well. This is going to be another one. Again, it's not symmetric to the y-axis, it's not symmetric to the origin, so this is a neither function right there. Alright, so there it is. You pretty much do everything the same. The only thing that's new, and really you know how to do it, is long division. And that's only when the degree is bigger up top. Okay, we will do number 2 in class tomorrow along with some other examples.